Hello, hello, hello. Welcome back to the STEM activity of the day. So today we are going to follow up or finish up our too much sugar experiment that we set up last week. So what the purpose of that was is that we wanted to set up our gummy worms, which are completely full of sugar. Sugar is the first ingredient. And when you're looking at nutritional labels, whatever the first ingredient is, it goes in order from most used to least used. So sugar being the first ingredient, that means it is made up of majority sugar. So we wanted to see how much sugar was actually in that. That's what we wanted to see. So what we ended up doing was setting up our gummies in a salt water solution and a sugar water solution. We wanted to see what the effects on the gummies was. So I'm going to tell you by my observation what I found, and I want to know what you guys found also. Hopefully you found something interesting with your observation. So hopefully you have your tools available, either this or a microscope, something that you can look in detail of what actually happened. So here are our two plates. We have our salt water. I'll move it back. And our sugar water mix. Okay, so what we can see is the water is pretty much gone from both plates. If you can see it, both, you don't see any water. Whoops. Well, a little bit of liquid is in that one, so be very careful. Have your paper towels nearby. This is the salt water solution, but pretty much all the water is gone. Just that little bit was there, and this was the sugar. So what I can tell from my observation is that the sugar, it expanded. So right here, what happened with mine is it expanded the gummies maybe by day 3. It expanded the gummies, so the gummies got bigger. Then it went back to its original size. But what happened with the water is the water part of the solution mix that we had, which was about 2 tablespoons of sugar to about a half a cup of water mixed together. All the water evaporated and left this almost gummy-like kind of gummy-like residue of pure sugar. So remember, we had 2 tablespoons of sugar in here and also the gummy sugar. So this is how much was left, and you see absolutely nothing happened with that. So if it was anything else other than sugar in this gummy, it would have been pulled out. So guess what is remaining in this gummy? Pure sugar. So you can see how much sugar is in your gummy by looking at the remaining amount of the gummy after our week of observation. All the water is pulled out. Anything that could have been pulled out through evaporation, through just letting it sit, it was pulled out. And this is all sugar, along with the 2 tablespoons of sugar that we mixed together with the water, and it left this really thick residue of sugar. So be careful with this Halloween. Now, what's really interesting is what happened with the salt. So again, what's in the sugar gummy remained. It's about the same size as this one. This one is a little bit bigger because it absorbed a little bit of that sugar water mix first and then dried out. So this is what was remaining. Here we go, hopefully you can see it. But what is fascinating is with salt, salt is a crystal. And as crystals form, they grab hold of each other, and different type of chemicals, different type of chemicals make up different patterns of crystals. So this is how salt forms when it's together. So I don't know if you're able to see this, but I'm gonna try to help you see this a little bit better. So if you can see those crystal formations, you can see that those are squares. Salt forms in a square pattern crystal. So if you have this in your home, because you were observing it during our STEM activity, you can take one of these and put it under a microscope and see exactly the patterns of the salt crystals. Unlike snowflakes, the crystals should come out looking the same. Unlike snowflakes where each one of them are different, crystals, you should see a very similar pattern. That's how crystals are identified. So, I hope you enjoyed observing this activity as I have. Here we go. Let's see if we can isolate one here. This is a really nice one here. Do not eat this. Maybe I should try something darker. Do not eat this. There we go. That's one square of salt crystal. And as you see, the salt was able to pull away from the sugar. It didn't mix itself in. It was able to form. May even have some mixes in here. Some of them looking a little different. So that'll be interesting to see what I can see under a microscope. So if you have a microscope handy, go ahead and see what you see. And if not, just take a close look of the crystal patterns. You'll see it's a square. It has a cross on the inside of it. It's pretty neat. And it formed perfectly into this square. No, I couldn't do anything to manipulate this into a square. It did it all on its own. So I thought that was pretty cool. The sugar probably activated the salt to form. I wonder if any sugar and salt mix combined creates this. That's probably definitely an activity that you can take hold of. Maybe pour a water sugar mix in one plate and a water salt mix in another plate and a water sugar salt mix in another plate and see how the crystals come out. If sugar forms in a crystal, I don't think it does. But what happens with the salt crystals and what happens to the sugar salt mix crystals? Because what probably happened was this probably is a mix of sugar and salt into this one crystal. So I'll be interested to see how pure salt looks and how pure sugar looks and how the mix looks and what are the differences between the three. So something very cool to take to school to show your friends that you made your very own crystals. Or as we did with our other crystal, dry the crystals off, paint it with some clear nail polish, and you can save them. You can save them as long as that clear nail polish seals it. You can save these crystals for as long as you need or you want to. So thank you for joining me on this STEM activity conclusion, finishing up on the salt water, sugar water solution of how much sugar is actually in gummies, which is a lot. So be careful this Halloween. So thank you.